Analyzing and solving polynomial equations. We have a trinomial here that we're asked to solve. So we're going to factor the trinomial using the reverse box strategy. We know that the term with the higher degree goes in the top left spot and the constant term goes in the bottom right. I multiply those together and I get negative 36x to the fourth. And now I start looking for factors of negative 36x to the fourth. And I'm trying also to see which of these sets of factors will add together to equal negative 5x squared. Now that I've identified the factors that I want to use, I put those along the diagonal, and now I factor out of the top row the greatest common factor of x squared. And x squared times x squared is x to the fourth. X squared times 4 is 4x squared. X squared times negative 9 is negative 9x squared, and just to check, negative 9 times 4 is negative 36. So I have factored the trinomial into the product of two binomials. The first binomial will factor as the difference of perfect squares. And at this point, we're going to apply the zero product property and set each factor equal to 0. The first equation, we get x equals 3 as one of the solutions or one of the roots. We get x equals negative 3. But this other equation, we know that any number squared is positive, and a positive number, or 0, plus 4 will never equal 0. So when we go to solve this, we're not going to get a real solution. We can take the square root of both sides here, and we're going to take the square root of negative 4, which is 2i. Remember, the square root of negative 1 is I. So for this particular equation, it was to the fourth degree, so there are 4 solutions. 2 of them are real, 2 of them are imaginary. We'll try another equation. Here, it looks like we're going to factor by grouping, but remember, we can also use the box strategy for that. And we simply put the x cubed and the negative 6 there, and then the 2 remaining terms of the expression go in any order. We'll factor out of the top row of the box x squared, and we'll just fill the rest of the box out. At this point, we definitely want to double check that 3 times negative 2 is negative 6, and it is. So the given polynomial with 4 terms factors like this. We'll apply the zero product property. And from the first equation, we know x equals 2, so there is definitely one real solution. From the second equation, x squared equals negative 3, again, there will not be any real number that satisfies this. We can take the square root of both sides. And the square root of negative 3 we call the square root of 3i. So one solution is the square root of 3i, the other one is the square root of 3i. So again, there's one real solution. There are 2 imaginary roots, the square root of 3i and negative the square root of 3i. For example, number 5, we're going to use the reverse box strategy. It's a similar process. We look for factors of 8x to the fourth. I found them. I put them along the diagonal, factoring out an x squared from the top, filling out the rest of the box. Now I write down the original trinomial as the product of these 2 binomials. And so by applying the zero product property, either the first factor equals 0 or the second factor equals 0. And we'll subtract 2 from both sides of the first equation. We get x equals plus or minus the square root of negative 2. So we rewrite that as an imaginary number, x equals plus or minus the square root of 2i. Similar process for the second equation, except the square root of negative 4 can be rewritten as 2i. So for this example, which was to the fourth degree, there are 4 solutions. There are no real roots. there are 4 imaginary roots. Okay, we're going to go on to problem number 7, new style problem. Here I have the difference of perfect cubes. Remember how we factor perfect cubes is a cubed minus b cubed factors into a minus b times a squared plus ab plus b squared. Okay, so that's in your notes. And now we set the first factor to 0, and we know that x equals 1 is a real solution. The second equation, when we set that equal to 0, we can tell right away this is not going to factor. So while we know there are 3 solutions, there is 1 real root. We will now show why there are 2 complex roots. Because to solve that equation, that quadratic equation, we will apply the quadratic formula, which I hope is in your memory. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we'll simplify under the radical. We call that the radicand. 1 minus 4 is negative 3. Now we can write our 2 solutions separately. Negative 1 plus the square root of negative 3 over 2, or negative 1 minus the square root of negative 3 over 2. Those should actually be rewritten with the letter I. The first solution should be negative 1 plus the square root of 3i over 2. The second one, negative 1 minus the square root of 3i over 2.